We're going to take a look at practice worksheet 2.2 extension. And this is number 5 and number 10 on the worksheet. So first let's look at number 5. This is the section that's talking about parallel, right? So obviously we're going to do something that has to do with checking to see if things are parallel. So it's asking the question, is the figure in the graph, is this a parallelogram? So first off, we know that it's a quadrilateral because it has 4 sides. But how do we know for sure that this is a parallelogram? Well, the definition of a parallelogram says that opposite sides must be parallel. So we're going to ask the question, are these two sides, let me use a highlighter actually. So is this side parallel to this side? Is going to be the first question. Second question is going to be, is this side parallel to this side, right? So we're checking to see if those opposite sides are parallel to each other. So I need to prove that AB is parallel to DC. So let's look at AB, the line AB. What is the slope of this line? Well, we see that it's perfectly horizontal, and we know that when we have perfectly horizontal lines, that the slope is going to be, let's see if I have enough room to do this. Take A, B. We know that the slope of a perfectly horizontal line is 0. Okay? And then let's look at DC. So D, C. Okay? Is this line also perfectly horizontal? Yes, it is. So that means it also has a slope of 0. Okay, so if those two have same slopes, that means we've already proven that these two are parallel to each other. Okay, so these are parallel lines. Now we're going to ask the question, is AD parallel to BC? Right? So we need to know the slope of AD and BC. So just saying, yes, they are parallel is not good enough. You need to give the slopes to show that you actually checked. Because for all you know, they could just be a slightly turned from each other, like we talked about before, and then eventually they would cross, right, if the lines kept going. So let's look at this. Let's take AD first. So I'm going to track this up. Notice that the degrees on my end are going up by 2, so I'm going to count in 2s. So it's going up 2, 4, 6, 8 over 2, 4, 6, 8. So up 8 over 8 means that we have a slope of 1. Okay, 8 divided by 8 is 1. Let's see if we have the same slope for BC. We're going to go up 2, 4, 6, 8. Okay, that's promising. 2, 4, 6, 8. Yep, and we land right at B. So this is also a slope of 1. Okay, so I just proved that these two have the same slope and these two have the same slope, right? Let me go ahead and highlight what we just did. We just proved that these lines are parallel to each other. And if that's the case, since these are parallel to each other, we can say yes. And if you're going to say yes, you need to give an explanation. So say something like, since AB and DC have the same slope, and AD and BC have the same slope, they are parallel to each other. Okay? Something like that. I'm not going to give the explanation for you. You need to do that. If you need to replay what I just said to help you give your explanation, that's totally fine. But you need to have your own explanation. Okay, we're going to do something very similar with the rectangle. Notice that this is number 10. This is on the side dealing with perpendicular lines this time. And so now we are already told that this is a parallelogram. So we actually already know that these opposite sides are parallel. So we're not trying to prove that right now, okay? They already told you that. So if I know that these are parallel, then I know this is at least a parallelogram, right? But the question is this a rectangle? what is the major difference between a parallelogram and a rectangle? Well, the only difference is rectangles are required to have 90-degree angles, right? That's the only difference there. You could take this, like look at this figure right here, that's a parallelogram. If you were to take this and slant this in a way, like make it upright, you would change all the angles, right? See how this angle is bigger than this angle right here? Angle A is bigger than angle B. If you were to change them to where you don't change the size of the side lengths at all, but you just change the angles to all be 90 degrees, you would have a rectangle. And that's exactly what we're going to ask here. Is this 90 degrees? And this is a big question mark, right? We don't know. You cannot just say, well, it looks like a 90-degree angle and call it a day. That's not going to fly. You need to use math to prove that these are 90 degrees. Well, how am I going to prove that this is creating a 90-degree angle? And well, the biggest clue I can give to you, or the biggest hint I can give to you, is that we were just proving two lines to be perpendicular. And what was the rule about perpendicular lines? Well, to be perpendicular lines, they have to cross at a 90-degree angle. So what two lines am I going to check now? I'm not checking opposite sides anymore. Instead, I'm going to be checking touching sides, right? Or adjacent sides. So I'm going to highlight the two that I'm interested in right now. So I'm going to try and prove that KL and JK are perpendicular to each other. So how do I know that these two lines are perpendicular to each other? Well, parallel says that they have to be the same slope, but perpendicular says that they need to be opposite reciprocal slopes. Okay, so if I'm going to check KL first, so KL, let's check that slope first, and then the next thing we're going to do is we're going to check JK, okay? And when we check both of them, we're going to see, are they opposite reciprocals? Well, let's find out. So I didn't add any numbers on the graph here because I just went up by ones. Okay, so we're just going to count them straightforward. So first, let's take KL. So I'm going to start with K, and I'm going to go down 1, 2, over 1, 2. Okay, down 2 to the right 2 is negative 2 over 2. Negative 2 divided by 2 is negative 1. Okay? Let's take JK now. So I'm going to start here. I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4. Okay, so 4 over 4, 4 divided by 4 makes 1. Okay, so I'm looking at these two numbers and I'm asking, are these opposite reciprocals? Well, from first glance, it doesn't really look like they are, but we have to kind of use a little bit of logic here to actually figure out the real answer to this. So if I were to take negative 1 and change it to a fraction, I get negative 1 over 1, right? And if I were to take 1 and change it to a fraction, it would be 1 over 1. This is why it was so important to simplify first, right? If we were dealing with 4 over 4 and negative 2 over 2, we would immediately assume, oh, these are not opposite reciprocals. No, you need to simplify the slopes first and then ask, are these opposite reciprocals? Because watch what happened. Now that we set them both as fractions, we're asking, are these opposites? Okay, well, this one's negative, this one's positive. Okay, so check, that has opposite. Are they reciprocals? If I were to flip these, if I were to flip the 1 and the 1 around, would I end up with 1 and 1? Well, yeah, actually you would. So these are opposite reciprocals. Okay, so the answer here is yes. The reason why I can just assume that this is yes is because I know that if this one's 90 degrees, I'm just going to assume that the rest of them 90 degrees. Normally in math, you would have to prove all of them, but for now, for the homework, I'm just going to say Go ahead and just prove that one of them works, and we'll call that good. We'll just assume that the rest are going to work as well, okay? So the answer is yes, and your reasoning needs to be something along the lines that these two slopes, KL and JK's slopes, are opposite reciprocals, meaning they are perpendicular, meaning that angle K is a 90-degree angle, okay? Which means it's a rectangle. And that's how you do number 5 and number 10.